All right, so in this video, we want to be talking about how to find the inverse of or the reciprocal of situations like when you have cot theta or cot x, when you have sec x, and when you have cosec x. So for instance, if you are trying to find the arc cot of a particular number, let's say 5, how do you solve situations like this? So that's what we want to try and find in this particular video. All right, stay with us. Now, if you were solving a question and you arrived at a place where you said cot x equals to 5, then the next thing to do is to try to say x equals to arc cot 5. And then you notice that you don't have this particular function on your calculator. So how do you go on to solve this? Well, let's examine something. From this place, you have that cot x equals to 5. So obviously, I can go on to say, instead of writing cot x, I can go on to write 1 over tan x equals to 5. Because cot x is actually equals to 5. So 1 over tan x, which is also cot x, I can place that to be equals to 5. If I decide to cross multiply this, I would have 5 tan x equals to 1. From here, we have my tan x to be equals to 1 over 5. Now, looking at this, you can see that my x here is equals to the reciprocal of tan 1 over 5. Now, looking at this, if you can notice what's going on here, we got, this is our x value here. When we were trying to find the arc cot, we said x was equals to arc cot 5. But we could not move through that route, so we went on to examine using the first scenario where we said 1 over tan x was cot x. That means from what we have been able to get here, that means we can see that instead of us doing our x being arc cot 5, we can go on to do x being arctan 1 over 5. So if you can notice what's going on here, our x value here was arc cot 5. The same x value is arctan 1 over 5. This brings us to a general rule. So the general rule is that whenever you have the arc cot of a particular number, say x, arc cot x, this will also be equals to arctan 1 over x. So it's a rule now that we can establish, because you can see x is arc cot 5 here, x is the same arctan 1 over 5. So if you have arc cot of say 0.5, rather than trying to solve that with a calculator, just go on to find arctan 1 over 0.5. So this is the rule we're establishing here. So if you go on to examine this for the 3 different reciprocals, you will notice that whenever you have the arc cot of a particular number, let's say x, you would be having the same number. The arctan of the reciprocal of that number will be the result. So if you have arcsec of say y, instead of finding arcsec y on your calculator, which is not very possible, just go on to find the arccos of 1 over y. Again, if you have a situation where you are supposed to find the arccosec of say z, any value, just go on to find the arcsin of 1 over z. So this is a rule that will always work. How do you find the arccot, arcsec, arccosec? when you don't have these functions on a calculator. All you have to do is to go on to find their respective reciprocals, that's arctan, arccos, and arcsin, and make use of, instead of the x value here, you will make use of the reciprocal. Instead of the y value here, you make use of the reciprocal. Instead of the z value, you make use of the reciprocal. Let's try and solve a few questions. So take a look at this question. You are told to solve for x. You are told to solve this equation. Now, if you decide to go on to solve normally, you will discover that you would have to multiply both sides by 2. So you'll be having cot square x equals to 1.2 times 2. That's multiplying both sides by 2. So this cancels this. So you're left with this. So we have cot square x will be equals to 2.4. And then you have to square root both sides. So you make the square root of both sides. You have cot x will be equals to square root of 2.4. And the square root of 2.4 is plus or minus 1.5492. Now, this is a scenario where if you wanted to go on to use a calculator, it's almost impossible because you'll be having to say x equals to arccot 1.5492. And in order to press this on your calculator, you won't be able to find a function of arccot. So what you have to do here to find your x value will be to go on to find the reciprocal of this. That will be arctan of, now not using this anymore, you'll be using 1 over 1.5492. So if you go on to find the arctan of that, you'll be getting a value of 32.84, which will be your x value. Now, I told you already that in a case like this, you have to solve for when cot was positive, and then you have to solve for when it was negative. And you have to do those things using your quadrant. So examining from your quadrant, all students take calculus. I told you already that wherever you saw cot theta, where you saw tan theta, your cot theta is represented here also. So that means your cot theta or your cot x is positive both in the first and third. So for the case when you had a positive 1.5492, your x value, because you are represented with x, so for quadrant 1 and quadrant 3, that will be your, for when your cot x was equal to 1.5492. So in this case, I told you in previous videos, what you have to do is to present your x here to be the value when you are dealing with the first quadrant. For more understanding of this, you can check out some of our other videos on how to solve all these things. The major point we're trying to make here is for the cot inverse, arccot. That's what we want to really try and do here. So for quadrant 3, we have x plus 180 as what we'll be doing there. That will be 32.84 plus 180. And that will be 212.84. So these are the two values for when we are dealing with cot x being minus positive 1.5492. So when we're dealing with the negative side, that means when cot x is equals to minus 1.5492, what we are having there is that your cot is negative because this is a negative sign in the second and the fourth quadrant. So we have the second quadrant and the fourth quadrant as a quadrant of interest. And the row that goes on in the second quadrant is 180 minus x. Your x being this same value here. So that will be 180 minus 32.84. And that will be what? That will be 147.16. So that's one of our values. Then for the fourth quadrant, the row that goes on there is 360 minus x. And our x is here. That's 360 minus 32.84. That will give you a value of 327.16. So we have this value 147.16, 327.16, 32.84, 212.84 as the answer for this value. So our x is what we have there, 32.84. Our x is also 212.84. Our x is also 147.16. And our x is 327.16. So this is how you solve questions when you are dealing with arccot of a trigonometric function. So let's try and see that of arcsec, and let's see how that goes also. So looking at this question, we are told to solve for x. Obviously, we are told to solve the equation, and we're given that 2 sec squared x is equals to 5. So again, we have to solve this using our knowledge of algebra. So we have sec squared x will be equals to 5 over 2, and sec squared x will be equals to 2.5. In this case, we have to make the square root of both sides. So we have sec x will be equals to plus or minus 1.5811. So in this case, we have sec as positive and negative. So we have to use our quadrant again to investigate for when x was positive and negative. But before we do that, let's quickly find the sec inverse of 1.5811. So what you have to do here is, as I said again, you don't have this on your calculator. So what you have to do is to go on to find your arccos. Sec theta or sec x is actually 1 over cos x. So you go on to find arccos of 1 over 1.5811. That's the way you solve. So if you do the arccos of what you have here, you will have x being equals to 50.77 degree. So what you have to do next is to go on to investigate using your quadrant. So you have to find for when your sec was positive and when your sec was negative. Don't forget, I told you already that when you're dealing with your quadrant, even though what was featured in the quadrant is the sine, cos, and tan, but their reciprocals are also part of the whole thing. So all student takes calculus. So here we have everything. Here we have just sine written, but don't forget cosec is also positive here. But here we have tan written, but don't forget cot is also positive here. And here we have cos being positive, but don't forget sec is also positive. So in this case now, when we have sec hex, where the sec x is actually going to be positive in both the fourth and the first quadrant. So our quadrant of interest when we're dealing with sec x being positive is quadrant 1 and quadrant 4. So when our sec x was positive 1.5811, our quadrant of interest is quadrant 1 and quadrant 4. That's where we have sec being positive. So for our quadrant 1, I told you already, what you do there is just to replicate what your first value was. So we have 50.77. And when you're dealing with quadrant 4, the rule that goes on there is 360 minus x. That will be 360 minus 50.77. In this case, we're going to be having the value of 309.23. So that's the value we get when we are dealing with the first and the fourth quadrant. So, but for when sec x was equals to the negative value of 1.5811, of course, in that case, if sec was positive in the first and fourth, that means sec is negative in the second and third. So the second quadrant and the third quadrant are quadrants of interest. The rule that goes on in the second quadrant is 180 minus x. In this case, we are having 180 minus 50.77, and that will give us a final answer of 129.23. And then for the third quadrant, the rule that goes on there is theta plus, not theta here, we're dealing with x. So that will be x plus 180. That will be 50.77 plus 180. And we arrive at an answer of 230.77. So with all what we have done here, our answer for this particular question, this is featured there, this is featured there, this is featured there, and this is also featured there. So we can conclude that our hex value for this particular question, we have our hex being equals to 50.77. If we have not made any error in any of our calculation, 309.23, 129.23, and finally we have the last one being 230.77. This is how you solve questions given the sec inverse of a particular trigonometric function. So I really hope this was clear enough. The same rule applies when you're dealing with cosec. So you can always tackle it with the same procedure. It's the same theorem. All right, guys, thank you so much for joining. Probably I should give you a question. Maybe you should. Can you investigate what's going to happen when you have 2 cosec square x equals to 7? What do you think this final answer will be? Can you investigate that and drop your answer in the comment section below? All right, guys, thank you for joining. Bye-bye.